Hello, and welcome to the presentation for Do You Still Trust Me? Human-Robot Trust Repair Strategies. My name is Connor Esterwood, and today I'll be presenting the work conducted by myself and Professor Lionel P. Robert. So to start out, we'll start with some details on our motivation. Humans and robots have been working together. We see this only increasing in frequency, especially as time progresses and technology gets more accessible. In working together, we see these interactions beginning to resemble teams. So these are situations where humans and robots are interacting in a way which is not so much, human to tool as it is something resembling more humans to humans, or at least humans to other intelligent agents. In most cases, due to this shift, what we see is robots taking on the role of social actors. And in that happening, trust becomes increasingly important. Trust becomes an increasingly important as it is a vital element in the creation of an effective team. So, one thing to note with trust, though, is that it changes over time. It's not a fixed state, so it can be broken. Fortunately, it can also be repaired. The human literature has detailed this, and it's pretty impressive how humans are able to repair trust over time and sort of keep relationships going. Robots could use this ability as well. One of the things that hasn't been examined is this idea of trustworthiness. Trustworthiness kind of determines when you will place your trust in something and is comprised of three different attributes. These are ability, benevolence, and integrity. It's not clear how different types of trust violations affect these attributes or trustworthiness in general. This is especially the case in human robot interaction literature, which brings us just to our first research question today, which is, do different trust repair strategies impact trustworthiness, ability, benevolence, and integrity, and how? An additional thing to keep in mind when looking at these effects is the idea of anthropomorphism. Anthropomorphism is essentially how human-like or machine-like a robot appears. We anticipate this as being influential here and perhaps moderating the relationship between different trust repair strategies and their efficacy, i.e., impact on trustworthiness, because it has been shown to be influential for trust overall. In addition, trust repairs have seen different effects in virtual agents, depending on how anthropomorphic or machine-like or computer-like the agent was. So we kind of expect a similar sort of thing to happen with robots as well here. This brings us to our second research question, which is, does anthropomorphism moderate the relationship between the impact of trust repair strategy and trustworthiness in HRI? So now we'll move on to our methodology and detail how we went about answering these research questions. We created a study design with 8 different experimental conditions, and these varied in the trust repair strategy that was utilized and the type of robot that was utilized. In this design, we used either an anthropomorphic robot or a machine-like robot, along with 4 different trust repair strategies. This was deployed on Amazon Mechanical Turk, and we detail that development process as well as the level of attrition that we had throughout our survey in more detail in our paper. Our repair strategies used in this experiment were apologies, denials, explanations, and promises. The apologies took the form of the robot sort of expressing remorse, and so this was, I'm sorry, I got the wrong box. Denials were the robot sort of denying that the event occurred, saying that it did nothing wrong. Something else must have happened. So the robot would say, that wasn't me. I picked the correct box this time. Something else must have gone wrong. Explanations were just kind of stating facts, so providing context. They're saying, yes, that was the wrong serial number. I see that. Not offering any regret or anything else, but just kind of stating that they recognized that it occurred. Promises were sort of commitments to improve in the future. So in our case, this was, I'll do better next time and get the right box. The type of robot in virtual environment you can see here on this slide. On the left, we have our anthropomorphic robot, which was based around Pepper, which is a highly anthropomorphized robot. And then on the right side, you can see the machine-like robot, which is just kind of your generic manipulator arm. These were implemented in our web-based scenario. You can also see here the screens that were displayed to the participant. The task that was used was a box sorting task and checking task. there were 10 boxes that needed to be processed, and the robot would pick the box, and the human would check to make sure it was the right box. And the correct box did not trigger any kind of repair, while the incorrect box triggered a robot repair of some form. Here you can see the user and the robot in the environment. The user is looking around, and this is the machine-like robot. It presents the human with a box, they check the number on the screen, and they approve this box. This is the scenario where the box number was correct. The robot then takes the box and puts it on a conveyor belt to be shipped outside. So now you can see here we're skipping forward a little bit in our scenario. The robot will pick up another box. This box is incorrect as a serial number does not match. The user will flag this as incorrect, and the robot will implement a trust repair strategy, and then the participant is directed to answer a survey. This concludes a quick summary of our methodology, so next up we'll go over our results. Generally, we found that repair strategy had a significant effect on the trustworthiness attributes of integrity and benevolence. We did not see this effect on ability, but it is worth noting that the p-value is not super high, so with a greater sample size, you could potentially see a significant effect here. Moving on to our interaction effects, we see a significant interaction for anthropomorphism on the effects of repair strategy and perceived integrity. Similarly, you can see here a marginally significant effect of anthropomorphism on the relationship between repair strategy and perceived benevolence. In this case, it is worth noting that the p-value is above a 0.05 but below a 0.1, so we consider this to be marginally significant. As a result, it is possible, and indeed likely, that anthropomorphism is playing a role here. So in closing, to sum things up, we examined trust repair in terms of apologies, denials, explanations, and promises. In doing so, we sought to answer 2 research questions. The first of which was, do different trust repair strategies impact trustworthiness attributes in unique ways? So, do apologies, denials, explanations, and promises change ability, benevolence, and integrity in a non-uniform fashion? Our results showed that these effects do vary, but it appears this is more so for the integrity and benevolence attributes of trustworthiness and less so for ability. It's worth noting, however, that these are preliminary results. So we'll see if ability remains non-significant as sample sizes increase and we get more participants over time. So our second question related to anthropomorphism. Specifically, does anthropomorphism moderate the relationship between repair strategy and the impact that it has on trustworthiness? This is again that ability, benevolence, and integrity set of attributes. In this case, we did see a significant impact, but only really for integrity and benevolence, the latter of those being only marginally significant. So now we can open up the floor to questions or sort of ideas for extending this topic. Again, this is early results, so I'd love to discuss it. If anybody has any other ideas or sort of critical thoughts, this is a great time to sort of present those to us. Thanks for your time and for listening.